This project has been a real fun effort in trying to take a heritage booster that had many, many years of reliability and great performance and evolve it into something bigger and better.
When we first undertook this design and qualification for the new booster, part of the mission was to make the booster more affordable and more modern, and of course it had to be completely redesigned for a new mission. It's a larger booster, and the mission profile is sufficiently different to where pretty much everything on the inside of the booster is different. There's well over 1,000 individual processes. Working with our customer, we were able to identify several hundred areas of improvement.
We've got totally new avionics on this vehicle versus what we had on shuttle. It's state of the art. We've taken that avionics and actually tested in development units in a full flight configuration and are about to enter some qualification testing with that system. But in this particular test, we will actually control the thrust vector control system with the flight avionics.
The old shuttle program utilized a rubber insulation between the case segment and the propellant that contained asbestos, and so we selected a fiber called PBI, which is used widely in the fire protection industry. Developed a new rubber formulation and ended up with a rubber that is actually higher performing than the previous material, which allowed us to remove a fair amount of insulation and replace it with fuel and get a little bit more performance out of it. So not only is it environmentally friendly, it's a higher performing material and a higher performing rocket.
Structurally, we've had to make some changes. The aft attach point of this booster, in order to accommodate the structural configuration of the SLS vehicle, has been moved several feet aft. And actually, this QM1 test will be the first test in a static configuration that we've done with that actual SLS attach point in place.
We had to design a new core and a new propellant grain inside the fuel that's inside the rocket. Part of that required us to design and manufacture all new tooling that forms the inside of the motor. We had to redesign our nozzle because we have a different performance, different things going on inside the motor, and so a large portion of the nozzle was redesigned.
Also, we've had a major effort over the last 2 years to try and improve the affordability of this vehicle, because the intent here was not only to have a higher performing vehicle, but to have one that actually costs less. And we believe we've achieved that, and this test of QM1 will be evidence of that culmination.